Okay, statics. Let's do another problem. So this is here going back to some of the stuff at the beginning of the semester. I asked my kids for inspiration for this one, so they gave me 3 animals to deal with. Bat number 1, Ben, and bat number 2, Sophia, are pulling on a rope that's connected at O, which is going over a pulley connected to a horse down below at A. And they are trying to pull this poor horse up. And we're given the weight of the horse, and we're given the fact that Sophia can pull 500 newtons. That Sophia can pull at 500 newtons at an alpha of 30 degrees, and we want to find the magnitude that Ben needs in the angle theta to lift this poor horse, keeping everything in equilibrium. So it'd be good if you could pause the video now, take a look at the problem, see if you can set it up and solve for it, and then come back and see how you did. All right. Okay, welcome back. So the first things you should recognize that this is basically a particle equilibrium problem in 2D, and it's going to make use of resultant forces. So the first thing we should do is draw free body diagrams. And of what? So there's actually 2 free body diagrams that you need to draw. One is a free body diagram of point A, and you're going to, because I want to start with the free body diagram of O. So let's actually do it that way. So this is point O, and it has forces FB, FS, and let's call this a force in our rope R. Now FS is known in magnitude and in direction, so we know that this angle is 30 degrees. We do not know theta, we do not know FB, and technically at this point we don't know FR, but I'm sure by intuition many of you have already done the free body diagram in your head of what's happening at point A. Of course we need coordinate systems for both of these. So we'll use the same coordinates that are in the problem. At point A, we have the weight of the horse. That's a known, equal to 1 kilonewton. And we have the force in the rope. And we know that the force in the rope must be constant throughout. And so this FR is actually equal to the same FR that's attached to the point O on the free body diagram on the right. And so of course here we can use sum of forces Y to tell us that FR is equal to WH. Okay, so now we can come back here to free body diagram O and look at that now that we know what we're trying to solve for. So FR is known. This is the 1 kilonewton. Well, we basically need to know how much force FB is so that this thing is in equilibrium. And as soon as Ben gets to that force or higher, as soon as he gets to at least that force, or just a little bit over, then he'll be able to start pulling up this poor horse. So we'll set up our 2 equations, right? So let's start first with sum of forces, X. So we have minus FB cosine theta minus FS cosine 30. I'm going to leave that as alpha for right now. Plus 1 kilonewton equals 0. Okay. So FB cosine theta plus FS cosine alpha is equal to, let me just go back to doing this symbolically. Sorry for jumping around here. Now we have 2 unknowns, FB and theta, so that's not going to get us anywhere. Should put round. Okay, so we need another equation. We'll use sum of forces Y then, right? This is the only other equation available to us in this problem because we're dealing with particle equilibrium. So let's take sum of forces Y, so that'll be FB sine theta minus FS sine 30, or alpha, equals 0. Okay, so we have 2 equations, 2 unknowns. At this point, you could throw this into MATLAB and solve for FB and theta, or you can do it by hand. If you do it by hand, I'm not going to show all the steps, but at least get you set up. So this is equation 1, equation 2. So from 2, solve for FB. right? So FB is equal to Fs sine alpha divided by sine theta. And then substitute into 1. Somebody's at my door. So, just a second. Just a second, Hafiz. One of my grad students is here, so I'll try and hurry up. FB cosine theta plus Fs cosine alpha equals Fr. And now plug in FB, so this is going to be Fs sine alpha divided by sine theta. So this is where knowing how to solve at least a fairly simple system of equation in MATLAB is going to really help you out a lot. At this point, what you really want to do is recognize that you're trying to figure out what this theta is, plus Fs cosine alpha equals Fr. With a bit of algebra, you'll get this theta isolated, and I think theta is about 27 degrees. And then given theta, you can come back to this equation here. And solve for FB. And from memory, FB is somewhere around 600 something. I solved it earlier. See if I can find 620. Around 620 newtons. Okay, that's how you solve that problem.